All right, well, I suppose we could at least do the preliminaries, can't we? So, just go and find it again. Unable to continue the session. What have I done here? Right. So, where's my documents gone? All right, so this thing seems to have got itself into a very strange state. Right, shall we kick off? So welcome to the PALS MPLS DetNet joint session at IETF 115. Come on. So why is this not? Oh, it's not sharing on this end here. I'll walk it down there. Right, so the usual note, well, you have seen this many, many times by the time you've been here. Just remember that, yeah, I can see that. I can't see it on here. Just remember that anything you say, why has that disappeared? Why has that disappeared? No. Share preloaded slides. Shares intro. Share. What am I connected to? I'm connected to IETF Hotel instead of IETF. Let's see if that works any better. Sorry, just bear with me. Share. Right, welcome to IETF 115, the PALS joint session. And please read the note well at your leisure. Meeting tips, I'm sure you've read this. The most important one seems to be to keep your mask on. Don't forget to get into the active queue rather than just line up at the microphone. So the purpose of this meeting, this is a meeting, is a joint session of PALS, MPLS and DETnet. And it's called to discuss the basic architectural issues and solution proposals arising from the need to improve MPLS support for new applications and uses. So the agenda is there will be a report on the open design team work. Then we will look at some updates on requirements, the M&A header and the IOEM encapsulation. And then there are two DETnet drafts that we've been requested to include on the agenda because it is felt that they need a wider community review. And so we're going to put them here in this joint meeting. And then there is some open microphone time to discuss issues of interest. So we had hoped that the Thursday open design team sessions could be drawn to a close and that we would revert to normal working group procedure and normal working group sort of timing and stuff. However, breaking news, because we only realized this last week, many of us being embarrassed by this. We don't believe that the solution properly describes how to do non-IP payloads and how they will be carried over an MNA-enabled LSP. So we're proposing to keep the open design team Thursday sessions running for hopefully a short while longer until we have a consensus position on how we're going to do payloads other than IP. So we've done the chair's introduction. Tarek, you're on next with an open design team report. Then we have a bunch of DETnet specific, M&A specific drafts, and then we'll go to the two DETnet drafts. And here is a bunch of useful resources that I suggest you consult at your leisure. Will this take me to change deck? So Tarek, over to you, please.
Okay, sounds good. Can you confirm you hear me well?
Yes.
Okay, great. Hi, my name is Tarek, and I'm going to report to you about the MPLS Network Actions Open Design Team activities. This is report number 4 that we give out, and obviously it's the product, the work is the product of the MPLS M&A Open Design Team. I don't have controls, so you'll need to help me a little bit with flipping slides.
All right, you tell me when you want me to move. You want to move to the next one?
Yes, please. So a bit about the design team itself. It's a joint activity between 3 working groups, MPLS, PALS, and DETnet. We meet on Thursdays, 11 a.m. Eastern Time as of now. The Open Design Team chairs also meet weekly on Tuesdays. We have good participation, around 15 to 20 people on a good day. A compilation of all the M&A documents are given on that link. There's quite a few of documents that were produced. Next slide, please.
Do you want to mention that we will be looking for volunteers to do the wiki migration?
I do, yeah. We can give a reminder on that towards the end, maybe.
I'm on the next slide.
Yes, this is good. I'll go over the Open Design Team working group documents and give an update on each very quickly. Some of these documents, they are on the agenda today, so authors will give a detailed update on them. Let me start with the first one. We have the use cases for MPLS network action indicators and ancillary data. The status of this document It was adopted back in May, and we added new test cases recently, IOAM direct export and generic function delivery in MPLS. The working group and the design team continues to refine this document and adding or updating the existing use cases as of now. The second document we have is the requirements for MPLS network action indicators and ancillary data. The authors have reported or have addressed another round of comments, specifically came from Adrian this time. And as of now, the document is in a stable condition, and it is a candidate for progressing further. Next slide, please. The third document that the design team has been concentrating on is the MPLS Network Actions Framework. The state of this document, again, addressed discussion points specifically raised in the weekly Open Design Team meeting. And we will go over those in more details in subsequent slides. There are currently no outstanding issues reported by the authors, and this document can be candidate of working group last call, can progress further. Next slide, please. So the update number one that we recently gave since last time, we want to report since last time, it's about competing M&A solution proposals. There were multiple of those that the design team has reviewed specifically for packet encodings for the M&A solution. Again, I'm giving the link where all the proposals are compiled in. The Open Design Team chairs encouraged the authors to meet and discuss and bring forward a converged solution. That was one option. The other option is to bring about a new unified solution. Maybe this unified solution can be cherry picking stuff from the different proposals. Now, the authors of the M&A solutions, competing ones, reported back to the Open Design Team chairs that progress has been made on a converged set of M&A solution documents. That's the status that we have. So we're going ahead with this assumption that we have, the authors are collaborating and bringing about a converged set of M&A solutions. Sorry, M&A solution documents. Next slide, please. The second update is about the order of M&A network actions. This was discussed in the weekly design team meeting, and the team has agreed that a solution should give a deterministic, explicit order of network actions. This need of order of evaluation needs to be articulated somewhere, and the conclusion was to add it into the framework document, and specifically in revision 1 reflected this agreement. Section 4.1 details that. I will not go word by word, but I'll leave it for people to go offline at their leisure. Next slide, please. The third update was about the MPLS network action scope. Again, this topic was triggered in the design team weekly meeting. Additional text to the M&A framework document was proposed to generalize the scope. We ran a poll on this text to solicit the support for it, and we concluded the poll with a good support. The text was reflected in revision 2 of the framework document, and again, I'm leaving it for reference, but it generalizes the scope of a network action. Next slide, please. The next update was a poll on the different implementations of an MPLS forwarder characteristics. There was a short questionnaire and a short number of questions that got asked on how existing forwarders, MPLS forwarders, handle special purpose labels. This questionnaire was triggered by the Open Design Team chairs in collaboration with Open Design Team members. The intention was to reveal any dependency that an M&A solution can have on existing implementations. The call or the poll was run for 4 weeks, and the responses were anonymously collected and reported in a draft that Adrian had compiled, and I'm leaving that link for reference. Next slide, please. So about the next steps that we have on the table for the design team, Stewart had mentioned there was an intention of continuing forward as normal, but then it's a question up for the design team as well as the working group on how frequent and is it a recurring meeting that we need for the design team moving on. So that's something we have to close on. The next thing is also touched upon by Stewart earlier is the discussion of non-IP payloads in an M&A packet. So that's another thing that we have to discuss in the design team. And progress the solution documents that we have converged on. So that would be the last bullet that I'm not showing. This is it. This was the report from the design team. I'm happy to answer any questions that I can have an answer for.
Any questions, comments? Gone.
Okay, thank you.
So Matthew will talk about requirements.
Thank you. So this draft is co-edited by myself and Stuart and John Drake. Next slide. So just a brief update on where we are with the M&A requirements document. So this document captures the key requirements for these MPLS network actions that affect forwarding or other processing of MPLS packets. And it's kind of broadly structured as general requirements, requirements on the substack indicators, requirements on the network action indicators themselves, and also requirements on the ancillary data. And these have mostly been derived by looking at some of the solution proposals for these additions to the MPLS label stack, also based on the use cases and some of the other discussions that have gone on and feedback we've had through these regular open design team meetings. And just to reiterate, these are requirements on the protocol design, not on implementations. Next slide. So we had a last call sometime around the last IETF, which we went through. We addressed those comments following the working group adoption. So there were so many comments that we had that we put them into an appendix in the draft, and then we worked our way through the comments in subsequent revisions. That appendix has now been removed. We also had some very detailed comments from Adrian Farrell, which we very much appreciated. Thank you. I don't see him in the room, but thank you for those. So we think we hope we've addressed those. We also renamed the draft to requirements for MPLS network actions to be more concise. And we've been doing some work to align the terminology and concepts as they've evolved in the M&A framework draft. Next slide. So the next steps, we've reviewed several versions of the draft line by line in the MPLS Open DT meetings. We think we may need to refine or add new requirements to this draft, depending on the outcome of the discussion on support for non-IP payloads with M&A. So that's things like pseudo wires and EVPN and so on.
And DebtNet.
and DebtNet. That's the ETC. Yeah. So please review the draft and post comments to the MPLS list. So I know Tarek mentioned this may be a candidate for working group last call, but I think as editors, we think maybe not until we've actually had some discussion on the situation with non-IP payloads and if there's any updates, significant updates needed to this document. Any comments?
Any questions, comments? I must say, I personally feel a bit embarrassed that I didn't notice this, given that I've spent 20 years of working on non-IP payloads.
Yeah, me too.
Right. G.
Hi, Jidong from Huawei. Hi, Matthew. Actually, I also made some comments on the previous version. I think I'm not sure whether I need to check the update, but I'm not sure whether all of them have been resolved or not. And since the issue list has been removed, do we have some other way to track the open issues with this document?
Yeah, thank you, Julia. I think we did address your comments. So yeah, I'm looking forward to you. Have a look at the draft and let us know if we've missed anything.
If we missed anything, it's mistake rather than anything.
Yeah.
Yeah. Well, so just please correct our human fallibilities.
Okay, I will also check the update. Thanks.
Lower, you're next.
For ye, it's actually possible to look at all versions on the data tracker, so you can find the appendix in the previous version.
Well, sure, but I think the question is whether we mistakenly missed some of his comments, and
then you can do a simple diff.
Right.
So, finding the appendix earlier version, do a diff, and you see if the comments are addressed. That's easy.
Well, I guess we will have a look as editors, but it would be nice if she could also take a look in case there is some sort of blindness going on our part.
Yeah.
Okay, is that it? Thank you very much. So it's number 3, isn't it? Did I pick the wrong one? Okay, so this one, header encodings. So I guess this is JAGS, is it?
Hey, could you hear me?
Yeah, quite quiet.
Yeah, could you hear me?
Yeah, go ahead.
Okay. Hello, everyone. My name is Jagan Babu Rajamanikam. I'm from Cisco. Today, I'm going to present the solution described in our latest JAGS draft on behalf of our authors and co-authors. Next slide, please. So we had a substantial contribution from a lot of people, so I would like to flash their names so that they are appreciated. Next slide, please. These are the abbreviations for your reference that are frequently used on our presentation and talk. Those are being displayed here. Yeah. Next slide, please. Today, we are going to discuss on the scope, the high-level view of our solution, some of the reserved network action opcodes used to build our solution, and discuss on network action ordering, backward compatibility, and the advantages. Next slide, please. The scope of this document is to provide a solution for MNA encoding format carried in the MPLS label stack by complying with our MNA requirement and framework document. Next slide, please. In a high level, this solution provides main building blocks for the Instack MNA solution. And the combination of these building blocks could be used to construct what the application needs. As part of this, the Instack M&A encoding contains two main parts. They are network action substack header and the network action encoding, in which network actions are encoded in the TLB format. Next slide, please. Okay, so the network action substack mainly consists of the M&A label and network action substack parameters, which are common and applicable for all the network actions encoded under the specific network action substack. A single network action substack could encode multiple network actions in it. Let us take a deep look at the network action substack content. So this header contains two main parts. The first one is the M&A label, and the next one is the network action substack parameters. The M&A label is a new PSPL value that indicates the presence of MPLS network action substack. The network action substack parameters are the common parameters; those are applicable for the network actions encoded in the substack. Let's take a deep look into the parameters. The P bit, this indicates the presence of post-stack network action, and IHS. This is a 2-bit value that indicates the scope of the network action substack. The scope could be ingress to egress, hop by hop, or select. And the NASL is nothing but a network action substack length. So this is actually a 4-bit value, indicates the length of the network action substack on the order of number of LSEs. And we have some reserve bits to be used in future. And the last bit is the O bit. So it's an ordering bit. So in some cases, network actions may require to be processed in order. So this bit indicates that the node must process the network action in the order it is encoded. Next slide, please. So network action encoding are encoded in the TLB format, as I described before. The NAI opcode is the type of the network action. Optionally, a network action could carry an auxiliary data. So this auxiliary data acts as a value, and the network action length acts as a total length of the network action encoded. That includes the auxiliary data. Some of the opcodes are reserved to create the basic building blocks of the Instack M&A solution, and the rest of the rest are available for the application use. There is an Instack opcode INA registry by which the application could allocate an opcode for themselves. So in case an application needs to carry an auxiliary data, then they need to define the data format and length that will be carried in the auxiliary data. And we have UOH, it's a unknown opcode handling. So all the opcodes cannot be implemented on all the nodes. So a node, when it finds an AI opcode and that it cannot understand, then this field will indicate how to handle those packets. For example, it could skip the unknown opcode and move to the next network action, or drop the packet, and etc.
Sorry, is that next slide?
Yeah, next slide, please. So here, actually, I want to describe a little bit more about the scoping. As we described before, each substack could belong to one of the scope. That's I2E, HPH, or select. Separate network action substack for each scope makes it easier for the intermediate nodes to process the hop by hop or select option. So a packet could carry all the three scopes simultaneously. The P bit in each substack will be set with respect to the scope of the post-stack data that is encoded. That is, if a network action substack has a scope of hop by hop and the P bit is set in the network action substack parameter, then it means that the packet is carrying a post-stack network actions with the hub by hub options. So
Right, next slide.
yeah,
Do you want next?
okay. So here are some of the reserved network actions opcodes, which I want to describe. This is used for our building blocks for our solution. In the NII opcode value 1, we have reserved it for carrying the post-stack data offset. So this will indicate the starting offset of the post-stack action header. Start from the bottom of stack. So in some cases, if there are cache or L2 informations, or no, the non-IP informations are encoded between the MPLS stack and the data. So even those kind of scenarios could be accommodated by using this offset, so that post-stack network actions could be encoded, not necessarily after the bottom of stack. It could be like even after some offset. So this offset indicates where the start of the post-stack network action is going to be encoded. And the next one is the opcode value 2. Is reserved to carry a flag-based opcode that does not require any auxiliary data to process the network actions. So we have a separate INR registry for applications to allocate their offset values. Next slide, please. Yeah, so the opcode. Sorry, you have any questions?
Did I move it across? I did move it across, didn't I? On slide
Okay.
11.
Yeah.
You, sorry, I'm interrupting. I just want to raise the attention that there are questions in the queue. Would you like to take them now or towards the end? It's a choice.
Can we do it towards the end after?
Sure. Thank you.
Okay. Yeah, thanks. So here, the opcode 3 is reserved to carry a combination of NAIs that may require AD. So it contains, like two fields, like NAI bitmaps and auxiliary data corresponding to those. Opcode value 4 is reserved to help maintain the ordering between the in-stack and post-stack network actions. In this example, we want the node to process the post-stack NAI6 before processing the in-stack opcode 8. So when the ordering is mandated, then the obit in the network substack parameters must be set. That indicates that we need to keep the ordering, and this new opcode 4 is going to say that I need to execute this post-stack NAI 6 before executing my in-stack opcode 8. Next slide, please. So here we reserve the opcode value 126 to fill in unused 20 bits. In some of the cases, like we won't carry the in-stack data, we only carry the post-stack data. So in those cases, this acts as a filler for the 20 bits of label field. And the P bit will be set to 1. That indicates the presence of post-stack data, and the NASL 0. So this indicates that NASL 0 and the 126 opcode is going to say that there is no in-stack, and the P bit is going to say that there is some post-stack data available. So that is the use of this 126. So currently we have 7 bits. It is maximum opcode we can have is 127. So for the future expansion, we reserve this 127, so that so in the future, actually, like if you want to allocate more than 127 opcode, then actually this 127 could be used for allocating the extension opcodes. Next slide, please. let's talk something more about the network ordering. In some cases, the network that encapsulates the MNA expects the other node to process the network actions in certain order. So the below example provides the framework for maintaining the order of processing the network actions. The orbit is one of the main building block of the ordering construct. This orbit must be set to indicate the mid nodes must maintain the order of processing the network action. In general, processing the network action in order is a complex process, especially ordering between in-stack and post-stack network actions. So we can't expect all the intermediate nodes can support this kind of a complex ordering process. So based on the node's capability, the node could drop the packet if it is not supporting the ordering. That could be a multiple types of ordering. That is, ordering could be between only in-stack network actions, or between only post-stack network actions, or between in-stack and post-stack network actions. The complexity arises when we have a network actions ordering between in-stack and post-stack network actions.
Next.
So in the
Sorry, do you want the next, or are you still on this one?
no, actually, I just want to describe just examples. In the first example, we wanted the instack opcode 5 to be processed before the instack opcode 2. In the second example, we wanted to process the flag-based NII opcode 1 to be processed before an instack opcode 5, and a flag-based NII opcode 0x22 to be processed after the instack opcode 5. So by ordering this way, we can ask the intermediate nodes to maintain their processing order. Yeah. Now, actually, can you do next slide? Yeah. So this is an example where the post-stack opcode 6 needs to be processed before the instack opcode 5. Here, the reserved instack opcode 4 indicates that the post-stack opcode 6 needs to be executed before the instack opcode 5. Yeah, next slide, please. So as a part of the solution, we maintain the backward compatibility with the TDL propagation and MPLS ECMP and coexistence of cache and other things. Next slide, please. So the solution as advantage, right? So the solution is more flexible to encode the network actions in desired order. The solution is also extensible in future. The basic constructs are hardware parser friendly. Yeah, next slide, please. Yeah, so we have some comments and feedbacks among our authors and co-authors. So we are trying to address those things, and we have some of the sections needs more clarity in our document, especially in the select scope and ordering. So these are the things we are working on currently. Yeah, that's it. Thank you. I can take questions now.
Right, we have a queue now. Lower, are you still in the queue, or is this a hangover from last time?
No, I'm in the queue.
All right, you go first.
Okay, so I have just one question. You claim alignment with the framework, but if I look at the abbreviation for network action substack, you use NASS while the framework use NAS. I haven't checked on the others, but there might be more. Is this something that will be updated?
Yeah, sure. Actually, we can update that NAS. Yeah, sure. I'll take a note of it.
And you actually should go through the abbreviations and look what the framework is doing and see if there is more.
Okay.
Joel.
Hello, Joel Halpern from Ericsson. Let me start by saying the overall approach here is fine with me. I don't have a conceptual problem or a fundamental objection. But if I have understood the draft right, and I'm not sure I have, there are a bunch of detailed concerns. One is sort of general. There are so many ways to do anything in this draft that when we get drafts that are saying, here's how to solve problem A or B, they say, well, you can actually solve it one way or another way or another way or another way. Look, if we have to solve every problem 4 ways, we're not going to get interoperability. Are we going to have every implementation support 4 different mechanisms to do the same thing? I hope not. That's a general comment. Now, 2 more specific comments. Let's take the first one, the simpler one first. You have this ordered bit, which you say it tells the processor whether it must process it in order. I don't understand what problem that solves. If I have to be able to process the things in order, because I may get something with the O-bit set, then I might as well code it to always process them in order, because that will be simpler than writing code that sometimes does them in order and sometimes juggles them up in the air and does them in some random order. As if we don't have a bit that has 2 different kinds of processing, everything becomes simpler. So I don't understand what problem the O-bit is solving.
Yeah, can I answer, Joe? Yeah.
Go on, answer, please.
Yeah, sure. So, Joel, if you see a network, right? So we have a mix of ASICs in the network. So some of them are capable of ordering, some of them doesn't. So if the end expects some ordering to be maintained, so then actually he can set the bit and say that this must be ordered, so that the intermediate nodes, which doesn't support ordering, can drop the packet. So that is the use of this O-bit. Basically, like to support, low-end ASICs where they don't support the complex things.
Either some nodes won't support the O-bit, which would create one class of, whoops, that doesn't work, or it seems simpler to just mandate that the O-bit isn't there and is always assumed to be set. I mean, I just don't see any advantage. In fact, the earlier discussion on the list, a lot of us said, just specify what order things must be done in, and then you can implement it. But okay, that's for the working group. I just wanted to point out it was one example of we have more ways to do things than seem to be useful. There's another more basic problem that worries me. And maybe I'm worrying about something that isn't an issue. But let us assume we have an MPLS label stack with 1 or more network action substacks and post-stack data. Now, as we go through, the network action substacks get papped off somewhere along the way. That's fine. So if all of them get popped off, we still have the post-stack data, and nobody knows there's post-stack data there. And when you go process the packet, whoops, what happens? And what happens if the last guy doesn't understand this new extension? Can we only use post-stack data if we're in the case when the last node understands this new service, in which case we better not be depending on post-stack data? So there seems to be some interactions between the network action substacks and the post-stack data and cleaning things up that at least need to be thought about. Thank you.
Yeah,
Greg.
Greg Mirsky, Ericsson. I have a question about PBIT and option 1, their relationship. So okay, it appears that PBIT, if you can bring this slide up.
Which one?
With the basic header, which has the.
You want to go back right to quite to the beginning?
Probably in the very beginning. Yeah. Next.
Yeah.
Yeah.
This is
I'll just go back.
no, go.
Yeah, or where, yeah, where their option one is explained. So probably next one too.
No, it's the next one after that, isn't it? No.
Yeah, so it appears that there are
Yes,
two
there.
ways, yes, so that there are two ways of indicating the presence of post-tag data object. So first, it's on a very high level in a p-bit. And then it tells then there is something in the post stack. Is that the case, or it's my misunderstanding?
So Greg, actually, I think there's a little bit of misunderstanding here. The PSD is not to indicate that there is a presence of post-stack data. So in general, right, so we think that the post-stack data will be coming just after the label stack. So in case, if that is not the case, if there is some data between the post-stack action header and our end of the stack, then how do we indicate that the post-stack data starts at this particular offset? So that is where the opcode 1 is used. So the pbit says that there is a post-stack data, and then offset says that at which point actually I can have my post-stack data. So this is an optional opcode. So if you say like in case like if you're creating if you're encoding the post-stack action header immediately after the MPLS label stack, then we don't need that this offset PSD offset at all.
But if opcode 1 is for post-tag data, then why there is need to do some other indication in the p-bit?
No, that's what I'm saying. That's only for the PSD offset we need to maintain, right? So if it's, for example,
right,
like
if opcode 1 to be used when there is a post-tag data,
it is not always to be used when the post-stack data is there. If the offset is not immediately after bottom of stack, that's where we use this opcode 1. If you see this figure, right, so I have some other data getting, like a cache or some other data is getting in between my MPLS stack and the post-stack data. Then how do we represent or encode those information as part of our header? So this is how we do it.
Well, as I understand it, gash is not to be used in data packets.
Okay, but that L2 words can be used, right?
Excuse me?
The L2 VPN control words can be used, right? So in those cases, like how do we inform the nodes that?
But control word is for pseudowire.
Yeah.
Well, non-IP services.
Yes.
Exactly. Exactly. So that's
So
what I'm saying. Like, doesn't matter, right? So like here, actually, we are. Has to work with everything.
no, but if there is a control word, then the interpretation is that control word is followed by the payload. Are you changing? Are you proposing to change the interpretation of the control word?
No. What here we are saying is that like if there is a possibility that if you want to add any such data after the MPLS stack, then still we use this kind of a basic opcodes to say where the post stack data lies. By default, if this is not specified, it is just immediately after the post stack data. Sorry, after the MPLS stack.
You're going to line up. This is clearly a longer discussion.
Yes, and I sense that since Jack, you brought their control word to the discussion, it definitely falls into what was identified as a gap that we missed to discuss non-IP payload.
Right.
Okay, let's do it in our
I think we probably
weekly
need
calls.
a talk to discuss that. So Matthew.
So I'd just like to kind of second Joel's comment about what happens if you kind of orphan the post-stack data. If you strip the stack somewhere and then then you terminate it, maybe in a PHP case or other cases, tunnel and tunnel kind of cases, the terminating PE essentially doesn't know what to do with that PSD or doesn't even know it's there. So I think we need a bit more thought about that.
Yeah, I think some people think that you can look at the bottom of the stack and determine what to do. I can tell you that this is absolutely not possible in the MPLS design.
Yeah. Similarly,
Yeah.
I think there's also possibly an issue with PSD and IP payloads if the PSD comes directly after the label stack, because it could alias for IP potentially, because this was a problem we tried to get around with control words.
Yep.
So we need to think a bit more about that, because we do have a general intention not to break anything that's in the network today, even if it's not necessarily standard behavior, it's common behavior.
And I think
Yes.
that the work that Adrian sort of did demonstrates that you can't really trust very much.
Right.
Matthew, actually, like when you talk about the post-stack data, which needs to be executed at the egress point, right? That's what Joel was also pointing out, right? So we have a slide number 20. Can you just go to slide number 20? That's 22, I think. Yeah.
Well, it's associated with the in-stack information, like the M&A label and so on.
Yeah.
So somehow you need to be able to process it where you strip the M&A label, where you see the M&A label. But I don't know if that's always possible.
Yeah, exactly. That's what actually we have a slide on that.
You're breaking into the service domain, if you like.
Yeah, that's what actually we have a slide on that. Can you just go to that slide 22?
Slide which one?
22.
20. Okay. Is that you?
The 22, like
21.
22.
22.
Yeah. So this is the exact case you are talking about, right? So I want to want my egress node to understand the post-stack data. So this is how actually, like we think the network stack, sorry, the MPL stack should be there, and this makes the packet to reach the egress, which has the M&A header, indicating that there is a presence of post-stack data, and that's going to be processed on the egress PE.
Okay, but that's just for the IP case, IP payload case, not for the layer 2, not the pseudo-wide case, where you presumably your PSD could be after the control word. So
that's right. That's what I'm saying. Like the PSD after control word, we have that opcode 1, right? So that's going to tell where the PSD is.
Yeah, but you're asking, if you're doing PHP, you're asking the PHP node to go beyond the control word. So it's not just popping the label stack; it's going beyond the control word into
right.
Between the
I
control
think
word and payload. But we need to think about this more.
We need to progress, I think.
Okay.
So, Vishnu?
Pawan Biram, Juniper Networks. Can you go to slide 11, please?
Slide 11.
So in the first illustration here, if I have multiple flag-based NAIs with ancillary data, how do I specify the scope? I have to rely on the one on the top. How do you specify the scope for flag-based NAIs in this particular?
So okay, you're not specifically talking about this one. Even the opcode 2 is a flag based, right?
No, flag-based NAIs with ancillary data, to be more specific. If I have flag-based NAIs with ancillary data, how do you specify the scope is the question.
So the scope are are grouped together. So only the scope, the opcode, sorry, only the if you say like hop by hop or E2E. So those NAI bits could be added in this specific network substack. So all the NA bitmaps, right, should belong to the same scope.
So if I'm defining a new NAI, flag-based NAI with ancillary data, what is the INR registry where I specify the scope? I understand that there have been some changes between 02 and 03. The scope-based registries seem to have disappeared. Is there any guidance on how to specify that?
So this NAA bit, this the subcode 3 especially talking about, right? Or in general, NAA flags also you're talking about opcode 2 also you're
Yeah, I
talking
just
about.
have a flag-based NAI with ancillary data. My understanding is that I would have to use NAI opcode 3 in that particular case.
Can we move on? I think this is definitely, I think I'm learning two things here. Firstly, that we definitely need to continue this this discussion. We really need to maintain our momentum of weekly meetings, because there have been so many discussions on this draft. I will say that I'll introduce a personal comment, if I may, at this point. I am really concerned at the complexity of this. MPLS was so successful and so fast because it was simple, and I just wonder whether we're destroying that heritage with some of this work. So I think we've got a bit to discuss before we get to conclusion. Thank you. So I guess we're on the next slot, which is data plane encapsulations for in situ. Isn't that not next? Who's presenting this? Ah, you might want this. Oh, no, you got one there.
Good morning, everyone. So my name is Rakesh Gandhi from Cisco Systems, and I'm presenting the MPLS NCAP for the IOM on behalf of the authors. Next slide, please. Next slide, please. So agenda is to look at the requirements and the scope of this work, the summary of the procedure and extensions, and the next steps. Next slide, please. So the requirement is simple. There is quite a bit of work that's done in IPPM working group. There's RFC now 9197 for the IOM data fields. There's also another draft for the direct export. They define trace points. And the requirement here is to carry them with MPLS encapsulation. We definitely want to do edge-to-edge as well as hop-by-hop processing. And the scope is the M&A. So this framework draft, JAX draft, songs draft. So these are all the drafts that's kind of normative for this work. Next slide, please. So history of this draft, we started this work a while ago, and it has gone through multiple iterations. We had the MPLS RT expert review as well. We had gone through GACH-based approach as well. And now it's aligned with M&A. So it's using M&A encoding as well as the post-stack extension header draft from Hayut. So these are the solutions that we are discussing this in the working group. So this is an example of how to use them. Next slide, please. This is using JAX draft. There is an M&A label, BSPL. And if you want to put IOM in the post-stack data, then the P bit is set. IHS is the scope of it, so it basically says should it be processed hop by hop or end-to-end or on select nodes. And then there are other bits like the length and O bit and whatnot that comes from the draft. Next slide, please. So regarding the scope, PBIC says that there is a IOM, and the scope says where it should be processed. This is exactly how it is in JAXtra. Next slide, please. So this is encoding using Hayut's draft for the post-stack extension header. There is a common header. It says how many extension headers are there, the length and next header. And what is this draft defining is the IOM as next header. And basically in the extension header, it would carry an IOM option type. which is defined in 9197 and other IPPM working group drafts. Next slide, please. So if you want to have multiple IOM trace points, there are use cases like you may want to do some tracing hop by hop, but maybe only collect end-to-end latency. So we would put multiple extension headers with their IOM option types defined in the IPPM. And the hop by hop needs to be, should be higher, should be able to easily access it, and end-to-end would be at the bottom. Next slide, please. So this is just a big picture how everything put together would look like. We have in-stack M&A and the post-stack IOAM data. This is a big picture for how everything fits together. Next slide, please. So in case of end-to-end, there are option types defined for end-to-end in the RFC 9197. So if you're doing end-to-end, that's what you would use. Needless to say that the DCAP node must support the M&A in order for this to work. There was a question on how would the DCAP node would just pop the M&A, maybe not the post-stack, but it would remove the post-stack as well because there's a P bit set, right? So it will detect that I need to remove M&A, but there's a P bit once. I also need to remove IOAM if I'm doing DCAP. In this case, there is no processing on the hop by hop. Next slide, please. With the hop by hop, there are trace points defined just for that. So we would use that. And again, the procedure is the same. Just the trace points are different, except now it gets processed on each hop, and the scope is set accordingly as well, so that M&A will tell the midpoint that you need to process this. Next slide, please. So we welcome your comments and suggestions. And I think we do have a few normative work that's happening. So once that's adopted, then we would request that this also be adopted as a use case draft.
Great.
Yes, Greg Mirsky, Ericsson. So as I understand, the proposal is to use pre-allocated and incremental IAM trace collecting data in the post stack.
So this one is about encapsulating it. So those trace points are defined in the IPPM, the RFC 9197. So it's how would you carry all these trace points in this in MPLS, and this is a way to carry it. So there is no recommendation on which one should be used for MPLS or should not be used.
I think that actually that's my question. Okay, so according to IAM RFC, pre-allocated and incremental trace options are to collect operational state and telemetry information in a data packet. So my question is, in MPLS packet, if incremental and trace and incremental and pre-allocated are used, where the data are collected?
So we expect that the pre-allocated is easy to implement. So wherever that extension, the post-stack extension header is, where IOAM data fields are defined, this is where the pre-allocated data fields will be, and it will be updated to carry timestamp, interface, whatnot.
Okay, so relative to the payload of the MPLS packet, where the collected data will be?
So this is after the bottom of the stack before the payload.
So before the payload?
Yeah.
Okay, so if, for example, their pre-allocated space is 1K. So then how much of the payload will be able to carry?
Not very much.
I mean, so these are the implementation and deployment details on what the hardware can do, how big it's pre-allocated, it can support. In theory, you can say 64K, but hardware may be able to do only 64 bytes. So it's a question when it gets implemented and what trace point to implement and what you want to capture. So it will be hardware capability thing.
Yes, and what's an impact of this IEM modes on a DetNet over MPLS data plane?
Yeah, so the draft doesn't discuss that, and it's just something we need to discuss and cover it.
Okay, and so for the incremental, so as I understand, incremental mode means that each node that is to add operational state telemetry information must add additional space to the packet. So that means that it needs to push the payload and rewrite the packet. So what's the performance impact?
So this is coming from IPPM RFC 9197. Definitely, it is understood that not many hardware can implement that. So if there is a need for it, we can explain that there is implications if you're doing incremental because you want to do hardware needs to move things around and hardware may not be capable of it. But yeah, it's when you implement it, those are the challenges you're going to face.
It appears that even though that the base RFC out of IPPM working group on IAM defines a number of different modes, we need to decide which modes are most applicable to MPLS data plane, because it's not necessarily that all of them are equally applicable. And for example, we have BFD that been defined for several modes, and only one of them being applied to BFD over MPLS LSP.
This sounds like it needs a detailed review beyond what we're going to do in the
Okay.
time we got on the agenda. But I'm not saying we shouldn't have this discussion, but I think we probably need to set up some special time to do it.
No, we can do it of, I agree with Rakesh. So once we have a settled encapsulation solution, then we can have this discussion
Right.
in the course of adopting this draft.
Okay.
Yeah.
Lower.
Yes. Just addressing the request for working group adoption. I think the document is pretty mature. However, it relies pretty heavily on draft JAX. So I would actually like to go ahead with draft JAX first before pushing this for a working group adoption poll.
Yeah, it also relies heavily on highest draft as well for post-stack extension header. So yeah, we need to stabilize the in-stack, post-stack first, get those adopted, and then come to the use cases.
Okay.
So-
My queue shows Kariti next, actually.
Hello, Kiriti Kampala. So I agree. I think we finally came to the same conclusion. There's a separate discussion on, what one can do with IOM, what's the implication on forwarding performance and so on. I think what you're talking about is how we encode it if you have an MPLS stack. And Greg, you have a good point that you might want certain modes, but not all modes. That is relevant to MPLS, but the actual IOM stuff is elsewhere. So
Yeah.
I think we kind of got there, but I
Yeah.
just wanted to reemphasize.
Could
Yeah,
you,
we are on the same page. Yeah, thanks.
you really need to be, I don't know whether you want to speak, but you should be in the electronic queue.
Oh.
But put yourself in it afterwards so that we've got a recording of who spoke, please. Just make your point and then just
This
log
is
in.
Howie Song from Future Way. Yeah, actually, I like to make the similar comment as Creative has made. I think the solution actually not just applicable to the IOM trace. There are many other different options. They can all be supported by the same framework. But as for the real implementation, I think it's up to the implementer to decide which option they will actually use in their design.
Right, thank you. And that's us done on this.
Yeah, thanks everyone.
Thank you. So we're now going in for a few minutes to work on the BFD RDI work. So who's presenting this, please?
And okay, this is Hong Huang. Can you hear me?
Yes.
Okay, let me begin. I'm from Huawei, and here in the joint meeting, I want to introduce our new draft about .NET OAM, namely BFD extension for .NET Remote Defect Integration. And this is joint work with Jian Tang and Tianran. And this is submitted to IETF for the first time. Next slide, please. And .NET provides reliable service for data flows with extremely low packet loss rates and bounded end-to-end delivery. And by dedicating network resources such as link bandwidth and buffer space and to .NET flows within a network domain. And as listed in IFC and A655, .NET has three strict cross requirements. And the first, compared to traditional IP network, and which neglects latency and leaves it to transport or higher layer, and IP adopts best effort delivery, and that aggravates the situation. .NET requires deterministic bounded end-to-end latency. And second, and .NET could operate a lossy underlay network, and it applies service protection to eliminate loss since it requires strict packet loss ratio. And the third is packet ordering function is applied to preserve order in .NET, and as it doesn't tolerate much out of order packet delivery. And next slide, please. And any violation of quality of service should be quickly reported. And in details, .NET OAM requires quick defect detection and remote defect indication, and we call it RDI in short. And bi-directional forwarding detection protocol is now commonly used, and it's deployed in forwarding client, and it can detect and report the numbers of failures, but it's not specific for .NET domain defects, and we mentioned before. Next slide, please. And so let's have a closer look at .NET specific defects. And we need detection technology, but this is out of scope of this draft. And we need methods for .NET RDI. In the aspects of latency and out of order, they are not well defined. And for packet loss, BFD provides insensitive methods, which is not suitable for .NET OAM. So currently, there are no explicit .NET specific defect indicators. And next slide, please. And so we need to define such defect indicators according to .NET quality of service. And they are the ratio of out-of-order packets and packet latency and the ratio of packet loss. And so next slide. And so the next step is how to achieve RDI. And we extend current BFD protocol as it provides diagnostic code field and in its control packet, and other methods to carry this information are all welcome to, and we can further discuss. And in diagnostic field, value 0 to 8 is assigned in IFC 5990 and 9 in another IFC, and others are reserved for use. Next slide, please. And so we follow similar method to append DATNet-specific error codes to indicate 3 main violations against DATNet clause, so as to guarantee the DATNet service and further later value localization. And they are packet misorder ratio limit reach and packet latency limit reach and packet loss ratio limit reach. And next slide, please. And our job provides 2 kinds of encapsulations in terms of IP and MPLS, as elaborated in DATNet OAM. And next slide, please. And so next steps, we hope to answer any question and receive feedbacks as we advise this job for the first time. Thank you.
Jeff, you're first in the queue.
Thank you. Jeff Haas, BFD Chair. Hongi, thank you for your presentation.
Yeah.
First question, this mechanism is not intended to cause the BFD session to go down, correct?
We want to first advertise it in DATNet section, and later we can discuss it in BFD session.
That is not my question. My question is, when the RDI is reported, the BFD session stays up, correct?
Yeah, we have it opened, yeah.
Okay, so I have 2 further comments. Comment number 1 is that the things that you're trying to detect, for DETNet purposes, packet order issues, latency, themselves can disturb the BFD session, and your timers would have to be much longer, to survive that. So this probably makes BFD not a good fit for your solution. My second comment and final comment is that there has been work previously discussed in BFD to carry additional information not intended to impact BFD sessions. Our conclusion in the BFD working group has been that this is not an appropriate use for BFD. We've had many discussions about this, but I also wish to give you the gift that Greg Mirsky has, in additional work, taken BFD state machinery and is proposing to carry very similar state that is explicitly intended to carry something like RDI. So my recommendation, 1, is that this probably would not succeed in getting code points from BFD, but you could probably work with Greg to actually advance your work. Those are my comments.
Thank you. Sasha.
Actually, I have nothing to add to the previous speaker. I was going to ask the same question and to comment that in any case, there is a recent errata on 5880 that said that the diagnostic code must be set to 0 every time the session reaches its up state. So I presume this means that the with the current BFD state machine, the diagnostic code either should be always 0 or simply ignored when the session is up.
Thank you. Any further comments? Right. Thank you very much. And finally, Right, Ren.
Hello, can you hear me?
Yes, go ahead. You're very quiet though.
Okay, hello everyone. I'm Tan Ren from Huawei. It's a pleasure for me on behalf of the co-authors Tara and Hongyi to make this presentation of our new draft. Echo request and reply for DNet capability discovery. Next slide, please. The agenda includes requirements of native solutions, pin trace route solution, DNet echo request and reply extension, and the definition of DNet capability discovery objects, and encapsulation example for the plan. Next slide, please. As per the draft IETF for DNet OM framework, DNet OM must support the discovery of DNet relay nodes in the DNet network and must support the discovery of packet replication, elimination, and order preservation subfunctions locations, and also must support the collection of the DNet service sublayer specific information from DNet relay nodes. Next slide, please. The alternative technologies include NetConf-Yarn, IDP flooding, or pin trace route. Next slide, please. As per the draft work, DNet service sublayer OM, it introduced a pin trace route mechanism, DNet pin, and mentions that it could be used for discovery DNet capabilities of DNet relay nodes. Next slide, please. In our new draft, we introduced DNet capability discovery objects to deliver DNet capabilities of relay nodes. These objects could be encoded in DNet echo request and reply packets, and they comprise of DNet capability metadates and an abstract object header has the corresponding format depending on the specific type of DNet data plan. The format of DNet capability discovery objects is shown as below. Currently, 4 kinds of objects are defined: DNet capability objects, DNet relay nodes identifier objects, DNet service protection function objects, and DNet service flow information objects. Next slide, please. When the initiator node starts a DNet ping to discover the DNet capabilities of each DNet relay node, the initiator node could send DNet echo requests that include a DNet capability objects, indicating that a set of DNet capability information is requested, like service and forwarding sublayer capability, as well as incoming and outgoing flow configurations. The initiate node will send DNet echo requests continuously and increased by 1 TTL each time. So all the relay nodes along the path of DNet service flow will be reached. When a DNet relay node receives a DNet echo request with DNet capability object and expelled TTL, it replies to the initiate node by a DNet echo reply, including a DNet capability object, indicating its correlative DNet capabilities, and a DNet relay nodes identifier object as its identification. Next slide, please. Three types of DNet relay nodes identifier objects are defined. It's MPLS IPv4 and IPv6. MPLS node was identified by a 20-bit node ID, while IPv4 and IPv6 node by its IP address. OP field specifies service operations capable on that node, including initiation, termination, or relay of the specific service. Next slide, please. Also, the net relay node capable of service protection could encapsulate service protection function objects in the DNet echo reply packets, describing supported sequence number length and service protection functions of packet replication, elimination, and order preservation. Next slide, please. DNet flow configuration on relay nodes could also be delivered by DNet service flow information objects. Incoming and outgoing flow information shares the same object format and differs from each other by the I and O bits set in the object header. The service label in the sub-object identifies a specific DNet service flow of MPLS dataplane. The P-bit indicates that the service label in the sub-object is allocated from the platform label space if set. Next slide, please. Service flow of IPv4 and IPv6 data plane is identified by the 6 tuple IP headers. That is the source address, destination address, source port, destination port, protocol, and DHCP. And optionally, the IPsec security parameters index or IPv6 flow label. Next slide, please. Next slide, please. DNet capabilities discovery objects defined in this draft may be used in DNet networks with different data planes and will have correlative formats. Take MPLS data plane as an example. DNet capabilities discovery objects could be encapsulated with the typical PLV header in place of the DNet capability discovery header. Next slide, please. Next steps. The aggregation and forwarding sublayer configurations could be collected. Encapsulation of different data planes should be specified. Sorry for the miswriting. Comments and suggestions are always welcome. Okay, thank you.
Okay, questions, comments? Do you have anything which you wish to say since this was DetNet specific, Lou? No. Okay. So I think that's the point where we get to open mic. And the original plan was, of course, to discuss whether we were ready to move into basically stop running the open design team meetings. I think we probably concluded that we aren't ready to do that. There's been quite a lively discussion on the in the chat room. I wonder whether we could usefully continue any of that face to face, or indeed whether any of my co-chairs have anything that they wish to say by way of introduction to the open mic. Lower, for example, Tarek.
We could use the remaining time to talk about discussion of post-stack data and where does it sit. There's some useful comments in the chat. we could bring them forward. And that's something, the audience, up to the audience and chairs. But it's a good topic to continue on, either now or later on.
So I agree with Tarek. However, I would like, Stuart, if you can elaborate a little bit on what you said about complexity and MPLS simplicity, to kick off the discussion.
So the processing model that I've always had in my mind for MPLS, I don't know whether it's everyone else's, but is that the way that MPLS works is that you describe in this protocol stack a vector to a block of code that you pre-positioned in the node. And that's an extremely efficient way of processing actions in the data plane. I can see why we need to add ancillary data to the packet. There are many new things that we want to do. For example, around latency control is the one that I think of. Greg clearly thinks of IOAM as another one. So clearly we need to make a space for that. But I am very worried when I see us move away from this vector to a predefined action model, to a model that requires us to pick apart components in the MPLS header and determine what we're going to do in what order. And I really am worried that we are destroying our heritage, not because I have any sort of particular nostalgia about it, but because it was a very effective method that was very hardware friendly. And I am just feeling a bit queasy that we are sacrificing that, and I'm not quite sure where it ends and whether it ends in tears. Well, that may be a minority opinion. Kariti is going to speak.
Hi, Kiriti Kompella.
And then it'd be Tony.
Yeah.
Oh.
Go on, Kriti, then Tony.
Okay. So I share your queasiness. I think there are a few features that we're putting into the new M&A approach. For example, processing at select nodes. I think that's something that we want to put in there just in case, but we don't actually have a use case for it quite yet. The ordering of things that you process, that's another thing that I think we're just putting in there, thinking that it would be useful. The efficiency of the representation, I think, has gone down. And so that means there's more to process. It's not like I have good answers for all of this, but I think that's a fruitful place for discussion going forward. And I will have those discussions. But you're not alone.
Okay. I mean, I'm not trying to be disruptive or anything. I would genuinely like us to make rapid progress. I just want to make sure that we make rapid progress in a way that doesn't destroy all this 20 years of really good work. Andrew, you look like you wish to take AD prerogative and go in XD9. I will put you next, Tony.
No, let Tony go. I'm talking without my AD hat on.
All right, okay. Tony, then Andrew.
Thank you. It's past basic queasiness and broken out to outright nausea. So I agree. There is no question that what we have created here is extremely complex. But once again, this is the result of the requirements that were put forth in our discussions. And arbitrary ordering seemed to be something that everyone wanted. If we can relax that, we can dispense with a great deal of this complexity. Being able to ping pong actions between in-stack and post-stack back and forth is insane. But that's what people wanted. So here's where we are. So if you
Right,
want to reduce if you want to reduce the complexity here, the place to start is to decide what requirements you can relax.
That sounds like a really good agenda item for as soon as we start meeting on Thursdays to see which ones. I mean, you won't get any pushback from, I don't think, from the requirements draft authors. We just want to do the right thing. Andrew.
So Andrew from Liquid, speaking entirely in my own capacity and without any AD hats on. I can see how we can make all of this work. Not a problem, right? But I have a concern, and this is where I kind of almost echo what you said, that because of the complexity here, we might get all this to work in the long term. There's going to be a point where people are implementing this, implementations are new, etc. And that complexity is such that I feel that we could well go through a very buggy period because of that complexity. And the danger to that is that if you give something to an operator and it doesn't work and it does have bugs because of the complexity, etc., you may steer them away from it. And once you've lost them, they'll never come back again. That's just the way that it works. That's what concerns me about the complexity here, that on the implementation side, this is complex enough that it could be buggy to a point of being broken for a long time, and that could end up killing it entirely.
Yeah, I'm not convinced that any of us are clever enough to figure out whether we've got this right. It's so complicated.
Yeah, exactly. And I think, so that's where my concern comes. It's about that complexity and saying that if we're not sure that it's going to work, let's be very sure before we push it. It's breakage. Yeah, we can kind of make it work later, but by that stage, you've lost the operators. You're never getting them back.
Yeah. Kariti, I think you want another go.
Yeah, Kariti Kampala. So I would propose something at this point. We were in a place where we had 16 reserved labels, not counting the standard ones, and we had used up 8 of them, and there was this concern, how quickly are we going to use up the rest, because of all these functions that we wanted, and they were all initially looking for independent code points. We're now in a place where we have 8 reserved labels left still, and we'll burn 1 for this particular new M&A indicator. And that will encompass several functions, maybe 10, maybe 20, And why don't we take the approach? We're stepping into this new waters, and let's keep the problem much more constrained, remove, to Tony's point, which I want to echo, remove a lot of the requirements and say, how does this work? And what does the implementation look like? And if we then come back and say, oh, we really needed that ordering, we burn 1 more. We have 8, and each of those can do multiple things. Once we've gone past the idea that 1 reserve label does 1 function, we don't have to boil the ocean with the first one we do. So let's put our toe in the shallow end of the pool and not pee in it right away.
Perhaps we could raise the tone of the discussion here. Okay, I think it's How You next.
This is Harrison from FutureWay. I'd like to add several comments regarding the ordering issue. I think so far we are still lack of tangible use cases to ask for actual ordering the use cases, the applications. So I think we'd better first find such a solid case than before we actually make design mechanism to support that. And secondly, I see some people comment that we might make it simple just to make the ISD action, in-stack actions to be executed before the PSD. But I don't think that's a reasonable assumption, because the reason we put an action in stack is not because it's logically it should be executed first earlier. Might be because it's just don't it doesn't ask for a very big data part, because we just simply cannot encode a lot of data in the label stack. If it requires a lot of ancillary data for this action, the better place to put it is the post stack. So that's the reason why we have this in-stack and post-stack separation, not because they're priority or importance, but because the data they require. So that means in which order we should execute them, it doesn't matter where it is, if there is inherently some order between them. So that's my second point. Combined, I think we need to further consider, because in many other scenarios like the IPv6 extension header, people also are proposing new applications, new use cases, but nowhere else I'm aware that people are talking about this enforce some order in the protocol design. I think for each use case, they have the semantics of the use case is clearly defined when it should be executed, and what's the meaning of each data is clearly defined by the use case itself. So I think somehow it's better for the implementer when they have these multiple actions appear in the same packet. They should automatically understand how to deal with them, but not just dictated by some ordering in the packet itself.
Thank you. How are you? Tony, remote, then Adrian in person.
I'd like to respond to Haoyu's comment. We went over why we needed ordering in the open design team meetings, and we went over that several times. I urge you to listen to those recordings again. There's not much question there. The only question on the table really is whether we want to backpedal from that requirement at this point. So I'll leave that to you.
Adrian.
Adrian Farrell. So to stretch the analogy a little bit further, I find myself one of the passengers on the bus screaming as it heads towards the cliff edge. I like the people on the bus, they're my friends. I like the color of the bus, but I would really like to not go over the edge. And so, yeah, I share Tony's nausea, I think. And I wonder if I've spotted a microleap. I'm looking at the abstract of the requirements document, and it says the requirements are derived from a number of proposals for additions. And it sounds to me that maybe what we are doing is talking ourselves into believing the requirements as engineers who are building the solutions that address the requirements that we are, and round and round and round. And possibly when, and I say this from not having participated in the design team, possibly we're not standing back far enough when we look at the requirements, because we're saying this is what we could do, here are our requirements, rather than this is what we need to do. And maybe we just don't know what we need to do, so we're inventing something that might be useful in the future. And well, that's yeah, interesting.
So I'm going to modify the queue order, so I'll let Matthew speak from the requirements thing. And maybe you hang around in case Haoyu takes us in the same place.
So Matthew Bochinok here. Yeah, I agree, Adrian. There was a little bit of where do we start with the requirements when we started with the requirements draft? Let's look at the solutions that have gone into the open design team, which is a bit back to front, to be honest. The requirements, in my view, should come from the use cases, not from the solutions. The solutions are a result of looking at the requirements. But the problem was the use cases weren't sufficiently documented at the time. So maybe we need to go back to the use cases and go back to the requirements and redo them a bit and look through what's really needed for the use cases we have. And there was also a lot of discussion about, well, maybe we should do things because you never know in the future, maybe we'll need it, or maybe we'll be able to support this on future hardware. But it's very difficult to design for the unknown.
Well, we'd save an awful lot less money spending a little tiny bit of time here getting this right than discovering we've got it all wrong.
Yeah.
Right. So running order, how you're next, then Tony, then G.
Yeah, some respond to Tony that certainly I am aware of the discussions in the open design team about this ordering issue, but I'm never satisfied with the cases or examples people raise there. One of the examples is probably for ordering the slicing and IOM applications, but I also explained actually it doesn't matter because what data to be collected for by IOM, the semantics well defined. It really doesn't matter how you put these two extension headers or ancillary data or what's their order is in the packet. You will you are guaranteed, you are required to do them properly. So in this case, I don't think that's a valid example, and yeah, yet to see some other real examples.
Thank you.
I assume I'm up. So I'm sorry how there is no assumption that we can make that you would automatically do it in the right order. It seems like if we say any implementation can do anything in any order, we exactly end up in the problem where you could do anything you wanted. This is also further compounded by the fact that we have agreed that we can have private actions. And we have no idea what the semantics of those private actions are. How do we order private actions in ways that we don't understand because we can't understand the semantics? So either we say that ordering is completely irrelevant, or we say that we have to have some kind of ordering and we have to specify it. And if we want to specify it and have general ordering, well, we end up back right where we are with full complexity. So takes our choices.
G.
Hi, Jidong from Huawei. I fully agree with what Adrian and Matthew mentioned, that we need to maybe step back and take a look at the requirement again. And to me, actually, the top priority requirement is to consider the backward compatibility so that we are sure that we will not break this network and we don't have a chance to break it and recover it again. And regarding the requirement on ordering, I think there's some discussion that maybe we don't need to a very flexible ordering specification, but just some of the actions can have a default ordering by themselves, regardless of the position in the packet. And also, if we want to really introduce some flexibility, we need some use cases to support it so that we don't over-engineer the solution. Yeah, thanks.
Thank you. Matthew again.
So I think one thing that might help, as well as simplifying the requirements based on the use cases, is maybe making the architect or the framework or architecture a little bit more prescriptive, a bit more layered, a bit more clear as to what exactly interacts with what in this. So at the moment, I feel I have to go to the solutions to look at how all the bits work together, and that seems to be jumping too far. There's no kind of meta picture of how everything glues together to see if it's really simple or not.
Tony, you might want to stay there, Matthew, because Tony's going to speak.
Matthew, please send text. I'm willing to entertain anything.
Thanks, Tony. Yeah, I will.
So maybe the three of us need a discussion on the telephone to try and sort of speed up getting there. or anyone else, wants to join.
Yeah. So that's typically what we've done. I mean, just in some previous kind of projects that followed this sort of model in the past, like MPLS-TP,
Yeah.
we had a fairly prescriptive architecture.
Well, that's been the history of all the pseudo-wire designs.
And the history of all the pseudo-wire stuff. We were quite prescriptive in the architecture.
Yeah.
And maybe that's sort of what would help here.
Okay, nobody else in the queue. Do any of the chairs wish to make any closing remarks? Lower, Tarek?
Thanks for the good discussions and everybody attending.
Lower?
Not much. Thank you very much for participating. It's been an interesting discussion, and I guess the chairs will have a coordination meeting on Tuesday. I will send out an invite to that. And then probably a design team meeting on Thursday.
Right, and I thank everyone for their participation, and I think we've moved on a bit from where we were. Hopefully, we will rapidly come to a conclusion, having taking in mind what we've learnt getting this far on the journey. Right. So thank you. Wait.